We are learning how the reaction between alkano and alkanoic acid, and kindly pay attention because I will not repeat when we come to alkanoic acid. We have seen ethanol plus propanoic acid, we get ethyl propanoid. Plus water. Now we said the starting of the word is ethyl from alkano, and the last one is from the alkanoic acid. That is propanoid from propanoic acid. The way we say sulfate from sulfuric acid. Now we want to do a chemical equation of the same. So we have ethanol equal to that our ethanol plus propanoic acid from propano 3 carbon acid is written that way. We have that. Now the functional group is that one of alkanoic acid. The functional group of alkanos is OH. So now the OH, the two combines, and that's why we have water. Now when we are drawing our product, we start with the acid, but the name starts with alkanotes. But when drawing structure, start with alkanoic. So we have propanoic. We have to start with 3 carbons. That way, remember there is this double bond in the alkanoic acid. Then the OH, we have oxygen. We don't put OH. H is the one that combines with OH in the alkano to form water. And then the next bond is the alkyl. Alkyl is from ethanol, and now our ethanol got 2 carbons. So you put the 2 carbon from the alkyl. And of course the other carbon, you fill the 4 bonds with hydrogen gas, with hydrogen molecules, atoms, to make 4 covalent bond of carbon. So this is the ester now, alkyl alkanoid. It is drawn starting with the acid from propanoic. We have 3 carbon. Then from ethanol we have 2 carbon at the head. And the functional group is hydrogen from the acid combined with the OH from alkano. This hydrogen here combined with OH in the alkano to form water. The second example is when you change and have ethanoic acid plus propanol. The name starts with alcohol, so the name is propyl ethanoate plus water, of course. When we come to draw the structure now, we have ethanoic acid, 2 carbon. We have that ethanoic acid drawn there. Then that is ethanoic acid plus propanol, carbon 3 carbons to propanol. Then we have remember OH from the alcohol. This carbon should have 4 bonds that way. This one. So that is now our propanol. In the product we get, let's draw it down here. We start from the acid. So acid is ethanoic with 2. I draw the 2 carbon. So we have 1, 2. Then there is double bond to oxygen. Now because instead of OH we have O. Then this one that way. So we have O, then the OH here, the OH, the hydrogen from the acid combines with the OH from the alkano and form water. So alkano has how many carbons? It's like it twists back, joins. This is the carbon that join the oxygen there. So how many carbons does propane has? 3. So I just have my 3 carbon that way. And then I fill the 4 bonds using hydrogen plus water. And I've seen for this reaction to occur in the hull, there must conk sulfuric 6 acid. Now this is now what we name or call as, the name of this one is propyl ethanoate. That is propyl ethanoate. That is how it is drawn. You start with the acid followed by an alcohol. But when it comes to naming, we start from the alcohol, then the one ends with the acid, and that is the ester, the substance with a pleasing smell, a process we call esterification. The condition necessary is concentrated sulfuric 6 acid. So that's how we form an ester. The number 4, the reaction, that was the number 3 reaction of alkano. And the other reaction is number 4, is alkanos can be oxidized. They can be oxidized to alkanoic acid. Can be oxidized to alkanoic acids. The process is called oxidation, and oxidation needs oxidizing agent, and commonly our oxidizing agent we use here are potassium manganate 7, that is potassium cheminophore permanganate 7, and potassium dichromate 6. Those are 2 oxidizing agents we use, and the 2 of them, of course, they are acidified, and we acidify them using concentrated sulfuric 6 acid, which act as a catalyst. So for this also reaction to occur, there must be concentrated sulfuric acid to acidify the oxidizing agent, or to act as a catalyst to speed the reaction. I've seen this cheminophore must be acidified. The process is called oxidation. We oxidize alkanos to alkanoic acid. This means when I have ethanol, then it undergo oxidation to become ethanoic acid. And also when I have butanol, it undergoes oxidation to butanoic acid. And for this oxidation to occur, there must be oxidizing agent. We are saying we normally use 2. 1, acidified potassium manganate 7. 2, acidified potassium dichromate 6. We are saying there is potassium manganate 7, and there is potassium dichromate 6. Potassium manganate 7 is color purple. This is color purple. When they oxidize alkanos, they turns to colorless because they are reduced. They are oxidizing agent, and therefore they are reduced to manganese 2 ions. that is Mn2+. These ions are colorless, but manganese ions, MnO4, these ones are purple. These ones are purple in color. These ones are colorless. So the moment you have an alcohol and you had potassium manganate 7 and it turns colorless, it has been oxidized to alkano. The same case when we have dichromate, acidified dichromate 6, we have dichromate 6 ions that are orange. These ones are orange in color and they are reduced to chromium 3 ions. Chromium 3 ions. Make sure yours is not joined. We say Cr3+. These are chromium ions which are green. And when you hand dichromate to an alcohol, it turns to green from orange. Then dichromate turns from orange to green, and they are reduced from manganate and from dichromate ions to chromium ions. And this is the confirmatory test for alcohols. When you hand something dichromate 6, it turns from orange to green. It confirms that that substance is an alkano. And in paper 3, it is the confirmatory test. So anytime you have dichromate 6 in alkanoic substance or organic substance, and you hand dichromate 6 ions, and they turn from orange to green, you conclude ROH present, because it is the confirmatory test for alkanos. And if you put dichromate in paper 3 and nothing happens, or the color does not change, of course the observation is orange potassium or orange chromate ions remains orange, and you conclude or negate the observation. You see ROH absent if the orange color does not change. But if the orange color changes from orange to green, then ROH is present. And I have seen the oxidation takes place when there is an acid that acts as a catalyst. So there is an oxidizing agent that is that oxidizes. So we have seen when we have our ethanol, we oxidize it in the presence of manganate 7 ions, which are acidified to get ethanoic acid, and of course plus water, ethanoic acid. So when I oxidize ethanol, I get ethanoic. The same case when I oxidize propanol, I get propanoic acid. And also the same way when I oxidize butanol, I get butanoic acid. We have seen it takes place in the presence of oxidizing agents that are acidified by conc sulfuric 6 acid. And the last part is of alkano. You have seen 1, combustion to form CO2 and water. 2, they react with the metal to form metal alkoxide. Number 3, they react with alkanoic acid to form an ester, esterification. Number 4, they are oxidized to their respective alkanoic acid. And the last reaction is they can be dehydrated, and they are dehydrated to form alkenes. And remember, this is how we said we can form, in Form 3, we can form a thin gas by dehydrating ethanol with sulfuric 6 acid, which is conch, and temperature between, I think, around 140 to 180, any temperature there is heating needed. So when we have ethanol, we have seen it can undergo, dehydration. The process is dehydration in the presence of conch, sulfuric 6 acid, and also there is heat, around 180 degrees Celsius, and they form the corresponding alkene, that is a thin. We can form a thin. Sorry, it should be CH2. That is a thin plus water. So ethanol can be dehydrated to form a thin in presence of conch, sulfuric 6 acid, and a temperature of 180 degrees Celsius as a condition to form a thin. And also when we have butanol, we can dehydrate it to form butene, and plus water. So butanol can also be dehydrated to form butene. And the last part, so that we can finish alkanos, is their uses. Allow me to use your book. Uses of alkanos. 1, as a solvent. Remember, in Form 1, even solvent extraction, we could use ethanol. And also in preparation of drugs, ethanol is used as a solvent. As fuels, but not when they are alone, but when they are mixed with gasoline. Ethanol, alcohols can be used as, alkanos can be used as fuels when mixed with gasoline. In manufacture of synthetic fibers, in the PVCs and polyethylene bags, polyethylene, we call them polyethylene, but they come from polyethylene. So alkanos can be used to form PVCs, polyvinyl chloride. And ethanol in low concentration is also used as an alcoholic drink. And because of alcohol and health, it is not supposed to be used by students or anybody under the age of 18. It is also used as antiseptic when specified concentration as an antiseptic. So those are a few uses of alkanoids. Yes.